Welcome to the second part of chapter Waves. In this part, you will learn about transverse and longitudinal waves. Mechanical waves can be transverse or longitudinal, depending on the relationship between the directions of disturbance or displacement in the medium and that of the propagation of wave. To differentiate it between them, let us consider the response of a straight string fixed at one end. If you give a single up and down jerk to the free end of this string as shown, a wave in the form of single pulse travels along the string. We assume that the string is very long as compared to the size of the pulse. So the pulse dissipates out by the time it reaches the other end, and therefore its reflection from the other end may be ignored. The formation of and propagation of this pulse is possible because the string is under tension. When you pull your end of the string upwards, it begins to pull upwards on the adjacent section of the string because of the tension between the two sections. As the adjacent section begins to move upward, it begins to pull the next section upward and so on. And in the meanwhile, you have pulled down your end of the string. As each section moves upward in turn, it begins to be pulled back downward by neighboring sections that are already on the way down. The net result is that a distortion in the shape of the string, or you can say pulse, moves along the string with a certain velocity v. If you move your end up and down in a continuous manner, then a continuous wave travels along the string with a velocity v. The wave has the shape of a sine or cosine wave. Conclusion: transverse waves are those waves which propagates perpendicular to the direction of the disturbance, and direction of disturbance is the direction of motion of particles of the medium. Longitudinal waves. Consider the production of waves in a long air-filled pipe by the movement of piston as shown. If you suddenly move the piston to the right and then to the left, a pulse of pressure along the pipe has been sent. The motion of the piston to the right pushes the elements of air next towards the right, changing the air pressure there. The increased pressure in this region then pushes on the elements of air somewhat farther along the pipe. Moving the piston to the left reduces the air pressure next to it. And if you push and pull on the piston in a simple harmonic manner, a sinusoidal wave travels along the pipe. The motion of the elements of air is parallel to the direction of propagation of wave, and such type of wave produced is called longitudinal wave. In short, the constituents of the medium oscillate perpendicular to the direction of wave propagation, and in longitudinal wave, they oscillate along the direction of wave propagation. A wave, transverse or longitudinal, is said to be traveling or progressive if it travels from one point of the medium to another. In both the cases, it is the wave or the disturbance that moves from end to end, not the material through which the waves propagate. In transverse wave, the particle motion is normal to the direction of propagation. So we can say that transverse wave can be propagated only in those media which can sustain shearing stress, such as solids and strings, and not in fluids. Fluids as well as solids can sustain compressive strain. Therefore, longitudinal waves can propagate in all elastic media. The waves on the surface of water are of two kinds, capillary waves and gravity waves. And it is found generally transverse and longitudinal waves travel with different speeds in same media. Given below are some examples of wave motion, and you have to tell whether the wave is transverse, longitudinal, or the combination. Take a pause and try to solve yourself. Now match your answers.